Now that we know about curve and surface parametrization, let's put this into action. Let's imagine that we have a pattern of curves drawn in 2D that we want to apply to this surface, which is not 2D from our perspective, but we know that it does have a two-dimensional domain, a u and a v. So let's use the parametrization of the surface to apply these curves on there. First, let's bring in our surface, params geometry, surface. Right click, set one surface, select our surface. I'll turn the preview off over here. What pattern do we want to apply? I'm going to go here to Vector, Grid, Triangular. If we look close, we see this tiny pattern of triangles. How are we going to get these triangles over here on the surface? Let's take a look. What I'm actually going to do, I'm going to go to Params, Geometry, Curve, and I'll pass the curves here. Now, I'm only doing this to make it easier later on in case we want to switch patterns. Maybe we want to add a hexagonal pattern or something else. So this will make it a little bit more convenient. What I need to do is I need to find some way to create a surface, a very small surface around all of this pattern. The surface is going to be a stand-in. It's going to be kind of a representation of this larger surface over here. If we make both of the parameter spaces the same, then we should be able to apply the curves from one to the other. What I'm going to do is I'm going to actually create a bounding box around all of these triangles. Surface, primitive, bounding box. Now, a couple of issues. First of all, we get a data tree from this. So we have various lists of all of our triangles. Second of all, the bounding box is set up to be per object. We actually want one bounding box around all of this. So the first thing I'm going to do is I'm going to actually flatten here in the input of the bounding box. I'll right click and I'll say flatten. Now the bounding box component sees just a list of curves. And then I'm going to right click in the center and change this to a union box, meaning that it's just going to give us one bounding box for all of the curves. So I have this flat box. I need to now create a way for this box to become a surface and that its parameter space is the same as the other surface that we have here. What I'll do, I'm going to go to params, geometry, surface, and I'm going to pass the box through here. So I'm converting this flat box into a surface. This also gives me the ability to right click and say reparameterize. Now the boxes and the surfaces actually parameter space is from 0 to 1 and 0 to 1. We should also do this for our input surface. Let's right click and say reparameterize. Now both of these surfaces have the same parameter space even though they are wildly different. This one's much bigger and curvy and the other one is just a flat box around our curves. How are we going to get them over? I need to know where on our surface these curves are. What I'll actually do is I'm going to go to Curve, Analysis, and I'm going to look at the control points. So let me plug in my curves there, and you'll see that I get the control points of my curves. I'm going to try to find where these points are relative to our surface. So I'm going to use Surface, Analysis, and Surface Closest Point, which is a bit strange because we know that the points are very much on the surface. What this is actually going to give us back is a UV point, not a point in 3D space, but a point relative to this surface's parameter space, which we've reparameterized. I'm going to plug the points into P and the surface into S. What we have actually are a series of UV points. We also have 3D points, which are just the same as these, but what's important about this are the UV points. And how can we use this? If we now go to Surface, Analysis, and use Evaluate Surface, we can evaluate our bigger, curvier surface with these UV points. Let me zoom out here and see what we got. It seems like I have some points along my surface because we've only transmitted or we're using the vertices of these curves as the data that we're passing over. But interestingly enough, because this set of curves gives us a data tree, we also maintain that structure. So if we look here, we actually have 4 points for each of these triangles. We have a point at the start and the end, that's why we have 4 points. But that means that I have all of the structure still remaining here. I can always tie back where these points came from. So I can go to Curve, Spline, Polyline, and now I get my pattern on the surface because we have the same parameter space on both surfaces. Let's increase the pattern and make this a little bit more interesting. Here in EX and EY, I'm going to create more triangles. I'll do a slider here, double click on the canvas, and I'll go 0 to 100. Let me plug that into EX and EY. See that I can increase, decrease the resolution. Let me turn off the points over here so we can see our nice pattern over the surface. In this case, because they're triangles, we should be able to actually make these flat panels. So I can go to Surface, Freeform, Boundary Surfaces, and create some planar surfaces. I can also go back to Rhino, change my surface. But what I want to do, I'm just going to hide it here briefly so I can see the triangles themselves. They look pretty nice. Let me go back here and start to play around with the resolution. I can get some pretty funky stuff at very low resolutions and increase it, and we can start to see more and more of the surface show up. I made it this way in order to be able to change easily the kind of curves that we have plugged in. As long as we can have, in this case, polyline curves that are flat, we extract their control points and we use that as the data that we transmit to the bigger surface. For example, if I go to vector, grid, and hexagonal, plug these into the curves, I get hexagonal curves. They're not going to eventually show up as flat surfaces because now we have more than 3 points and they're not necessarily going to be planar. But I could also grab the slider, I'll make it a little bit lower this time, and I can start to play around with hexagons on the surface. Really, any flat pattern of curves, in this case, it's probably easier to have them be polylines, will work very well. We can switch back and forth between triangles, hexagons, you can even bring down squares or rectangles. In this case, it does seem like we got a few planars. It's very easy now to switch between any of these curve patterns. You could also, of course, bring in your own curve pattern as long as it's flat and polylines. It should work just as well. Again, this is really taking advantage of the fact that we can have multiple surfaces with the same parameter space and we can transmit UV point data from one to the other.